We are go. All right. So review day 1, 14, 19. Okay, a couple of things. Now, first of all, we got to go back to direct, inverse, or neither. Okay, so if you go back to direct, direct is going to be y equals like kx plus 0. Okay, so if it's direct, there's straight lines and they go through 0. If it's inverse, it's just x times y equals some number. Okay, that's inverse. Okay, direct is a straight line. It's like y equals mx, has to go through the origin. Okay, inverse, x times y equals some number. Okay, neither means it's going to be neither one of those. Okay, so right off the bat, number 1, yeah, that's definitely got to be inverse. It fits the model. X times y equals a number. That one's got to be inverse. Number 2, it's straight, but it doesn't go through 0. Right? It's straight, but it doesn't go through 0, so it's neither. Okay, so this one's neither direct nor inverse. It's neither. Because of the plus 3, it does not start at the origin. So we're going to say neither.
Because it starts at plus 3.
Exactly. Yep. Number 3, it does start at plus 0, and this would be a straight line. It starts 0, up 1 over 2, up 1 over 2. So this one's going to be direct. So to be direct, I'll draw a picture. It's got to go through 0, and it's got to be a straight line. To be direct. Okay? How am I doing? Okay? Now number 4. If I'm not sure, one of the things I can do is we could actually graph it. I mean, I can see what it is. So if I were to graph it real quickly, and I'm not sure what it does, if I do a little graph here, and I'm going to go something like this, I'm going to go 2, 1, 4, 2, 8, 8, 3, 1, 2, 3, 4, 5, 6, 7, 8, 3, 16. Oh, you know, it almost looked like it was going to be straight. I almost thought it was. I almost thought it was going to be direct. In fact, let's check this out. The first 2 points made it look like it was going to be a direct one, right? But then it starts to curve on me. You see that? So since it curves, it can't be direct. And 1 times 2, 2 times 4, so this one's going to be neither. It's not straight, right? And it's not this times this equals the same number. So this one's going to be neither. But by graphing it and looking at it, it really helped me figure out what it was. Okay, number 5. Let's look at 5. Again, I'm not sure. Sometimes I graph it. Okay. So if I've got a 1 and negative 8, 1, 2, 3, 4, 5, 6, 7, 8. If I've got a 2 and a negative 4, I've got a 4 and a negative 2. I've got an 8 and a negative 1. You know, this looks curvy like what we've been looking at, right? So then I'm thinking, that sure looks like my indirect. It sure does look like my inverse. So then, one of the things about inverse is like it's an x times y equals some number, right? Okay, I can do this. Let's see. 1 times negative 8 is negative 8. 2 times negative 4 is also negative 8. 4 times negative 2 is also negative 8, and 1 times negative 8 is negative 8. So it's always equal to negative 8. So it's an x times y equals a negative 8. Well, that's got to be my inverse. It follows my inverse perfectly. So that's an inverse one, okay? Again, if you get stuck, remember that your inverse variations look like this, and then of course they got the other side too, right? And your direct variations go through 0 and have to be straight. Always works if you can see it, right? Okay, let's look at number 6. I'm going to do 6 on a separate sheet of paper because I'm just not going to have room. So, number 6. Let's take a look at it. So on 6, we're going to see that the variables x and y inversely. So that's x times y equals some number. Okay, we learned that. That's in our notes. Okay, so x times y equals some number k. So let's figure out what k is. If y is negative 3 and x is 5, so let's see. We're going to go 5 times negative 3 equals my value k. So here's my equation. I just need to find k. Find k. Let's plug in my negative 3, my 5. And so in this case, k is negative 15. So now I can make my equation. It's pretty easy. And I can make my equation. And my equation's going to be just x times y equals negative 15. Awesome. That's my equation. So once I make my equation, let's use my equation to get an answer. So let's plug in negative 4. So I'll plug in negative 4 in for x, and I'll go, okay, I'll go negative 4 times y equals negative 15. And I'll solve, right? So I'll divide by negative 4, divide by negative 4, and y equals, let's see, 15 divided by negative 4. Oh, must be a negative 3 3/4 probably. Negative 3.75.
We'll do it on the calculator.
Say again, Autumn. Did I make a mistake? I do.
It is negative 3.75.
You are so right. Thank you. I agree with you. I dropped my negative there. Thanks, Autumn. How am I doing? Not too bad. You guys can do this tomorrow, right?
Yes,
It's pretty
sir.
simple, isn't it? Okay, now, let's start 7. Now, if you cannot factor by now, then there's nothing I can do for you. If you can factor, then these aren't going to be too bad, okay? Number 7, I have an x squared plus a 5x over an x squared plus 10x plus 25. So, factor. Do not cancel x squareds. Do not do that. You can do that right off the bat, then you are going to get it wrong, okay? Factor. So if I factor, I'm going to common factor out an x. I'm going to have an x plus 5, okay? Common factor out an x for the numerator. And in the denominator, I'm going to go 5 and 5. 5 and 5, because that'll make it 10. I'll go x plus 5. X minus 5. Okay, now can this fraction be reduced? Heck yeah. I can reduce this fraction because I'm going to cancel out my x plus 5, and my reduced fraction is x over x plus 5. Oh, and so bad if you can factor, right? Can't factor, that's a real bummer. That's it.
Yeah.
Okay, number 8. There's 2 ways to do it. I'm going to do it the most basic way. My particular way is a little bit but I'm going to do it this way. Okay, 12y divided by a 6x to the 7th times 4x to the 5th over an 8y to the 4th. Okay, now, I like to cross simplify and cross reduce, but I'm going to make it easy for you. Let's just multiply, okay? I'm going to get 48 y x to the 5th over a 48, oh, I kind of like that, x to the 7th, y to the 4th. How am I doing? Yeah. Okay, I just multiply. All I did is just multiply it straight across, right? Now we can reduce. 48 over 48, boom, 1, right? One of these y's here will cancel out 7 of these, or one of these. So if I cancel 1 for 1, I'm left with an x to the, oh, sorry you guys, my bad, the y's. One of these y's for one of these y's makes a y to the 3rd. Okay, 5 of these x's with 5 of these x's leaves an x to the 2nd. What's left on top? A 1, because 48 over 48 is 1. Okay. Yeah. There you go. I'll turn the page when you're ready, okay? So I just canceled, right? Just canceled x's with x's and y's with y's. Okay, turn the page. Okay, number 9. Hopefully I'm not going too fast. Okay, number 9 is a pretty big looking fraction, but then I think if I can factor and cancel, it's going to be nice. I get a 2x squared plus a 2x over an x squared minus 3x times an x squared minus x minus 6 over an x squared plus a 2x plus 1. Okay, factor. We're going to factor, okay? Got to factor. So we're going to factor. So the numerator on the first fraction, I can common factor out a 2x, and that'll leave an x plus 1. Okay? Common factor out of 2x, be left with a x plus 1. The denominator of the first fraction, I'm going to common factor an x. I'll have an x minus 3 times, okay, the second fraction. Second fraction, factor. On the numerator, x minus 3 times x plus 2, because multiples negative 6, that add up to a negative 1 or negative 3 and 2. Factor the denominator of the second fraction. How about 1 and 1? Because 1 times 1 makes 1, and 1 plus 1 makes 2. So we're going to do x plus 1, x plus 1. Now, we're going to reduce the fraction by canceling anything on the top, anywhere, with anything on the bottom, right? So this x with this x is gone, right? Jay, put the phone away. Okay. This x plus 1 cancels x plus 1. This is the fun stuff, okay? Oh, right here. X with x right there. X minus 3 with an x minus 3. Now, we've reduced this fraction a whole bunch, right? It was a big, ugly fraction. Now we've reduced it to 2 times an x plus 2 over an x plus 1. That's it. Can't reduce it any more than that.
Wait. How are you? Never mind.
Okay. Always ask Autumn, because half the time I make a mistake and you catch me, okay? Okay, you guys ready for 10? 10. I've got a 5x squared over a 7 y squared divided by 15x squared over 35 y to the third. Now, when we divide, we're going to flip. It's called invert and multiply, right? Remember that from middle school? Anytime you divide fractions, you flip it, right? So you invert and multiply. So what I'm going to do is go my 5x squared over my 7y squared times, and I'll flip it, okay? 35y cubed over 15x squared, okay? Boy, to make it easy, do you mind if I just cancel these x squareds right off the bat? Do you see that? Right? Cancel that right off the bat. And then let's multiply. 5 times 35. Or I can cross simplify. You know, I like to cross. Can I show you cross simplification? It's so much easier. 5 and 15. Can you reduce 5 and 15? Yeah, to 1 and 3. You okay with that? It's so much easier to cross simplify. 7 to 35. You guys see the 7 to 35? Cross simplify that into a 1 and 5. This is the way I like to do, okay? Y squared, y cubed, I can cross simplify that into a plain old y, because 2 of these cancel 2 of these. Now what I got left over? This is easier, I think, than just multiplying and reducing. So what I got left over? I got a 1 times 5 is a 5 times a y over a 1 times 3, and there's my answer. If you don't like the way I showed you, you can always multiply straight across and then reduce. For me, I like to just cross. How many kids like that cross simplification? Much easier, right?
Oh.
Cancel before you multiply, you guys agree? Make it smaller and then multiply across, okay? I like it that way too. Okay, 11, how am I doing? Okay. All right, how about number 11? Okay, big, ugly fraction. Let's see if we can make it look nicer, okay? I've got a 2x squared plus 5x plus 2 over an x squared minus x minus 6 divided by an x squared plus 3x minus 10 over an x squared plus 2x minus 5. Ooh, that is one. So the whole reason we have this chapter is sometimes you get problems like this. They are big, bad, and ugly, right? This is big, bad, and ugly. So let's go ahead. If it's divide, we're going to flip this one, right? We invert and multiply, right? Just like 6th grade math. We're going to flip this one, okay? So let's rewrite it. So we're going to go 2x squared plus 5x plus 2 over x squared minus x minus 6 times. Remember, 6th grade math, we invert and multiply. Okay, it's a big, ugly fraction, but when I'm done, hopefully we'll have a nice answer. So I flip this, x squared plus 2x minus 15 over x squared plus 3x minus 10. Okay, now, still a big ugly fraction. Doesn't even look any better, does it? But if we factor, we're going to factor, and hopefully then we're going to cancel. Factor, 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 factor. Then hopefully we'll cancel, 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 cancel. This big ugly fraction is going to look much nicer. Okay, so if I factor the numerator of the first fraction, I'm going to go 2x, x, plus 1, plus 2. Okay? Do you see the 5? 4 and 1. There's my 5, okay? If I factor the denominator of the second fraction, there's a 1 there. I'm going to go x minus 3, x plus 2. Okay, I already see something I can cancel, but I like to cancel at the very end. But I already see something I can cancel, right? Okay, let's look at the second fraction. Let's factor the numerator. X plus 5, x minus 3, because I've got the multiples of 15, negative 15, then make a positive 2. And the denominator of the second fraction, let's factor that into an x plus 5, x minus 2. Okay, big, ugly, gross looking fraction now is going to start to look nice, okay? You ready? So let's see what I got. I got that with that, right? X plus 2, cancel x plus 2. Here's the fun stuff. This part I like to do. Cancel, cancel, right? X plus 5 with an x plus 5, right? And way over here, anything on the top with anything on the bottom, x minus 3 with an x minus 3, okay? I don't think I can cancel anything else, but it doesn't matter. The whole big ugly fraction now is nice. Small. Yeah, 2x plus 1 over an x minus 2 is my answer. How's that? Went from big ugly to something really nice and small, okay? Yep. Okay, you guys ready for 12? Scoot it up. So, 12, we've got x minus 3 over a 2x plus 1. Subtract an x plus 9 over a 2x plus 1. Okay, when we add and subtract, okay, write yourself a note. We're adding, subtract. Add, subtract, you need a common denominator. Right? Go back to 6th grade math, always. Add, subtract, you need a common denominator. Well, the beauty about this problem is you already have a common denominator. So my common denominator is 2x plus 1, right? So I get my 2x plus 1. And let's see what we get on the bottom. We're going to have then a x minus 3 minus an x minus a 9, because I brought the negative over, right? Make sure I brought the negative to the 9. Don't forget that, because I'm subtracting both of them. Okay, now let's see what I got. Well, x's cancel with x's, right? Negative 3, negative 9 makes a negative 12. So I'm going to have a negative 12 over a 2x plus 1. Okay.
Just cross the x's.
Yeah, because it cancels. I got a positive x, negative x, right? Yeah, good point, Jay. Pretty easy?
Yeah.
Okay, guys ready to turn the page? Well, I'm turning the page. This is my page, okay? All right, 13. Let's look at 13. Some of these aren't so bad, right? All right, 14 is going to be the hard one, but we'll have one hard problem. We can do that, okay? 5x over x plus 2 plus x plus 12 over x plus 2. Okay, need a common denominator. Whoa, I already have one, don't I? Need a common denominator? I already have one. So it's just x plus 2. So if I add, I'll have a 5x plus an x plus 12, right? And I can add 5x and x so that I get a 6x plus 12 over x plus 2. Now normally I'd be done, but this fraction will reduce. This fraction is going to reduce because I can factor, right? So I'm going to factor. And if I factor out a 6, you see that? I have a 6 times an x plus 2. Because I can take out a common 6. And in the denominator, I have an x plus 2. So what are we going to do? Let's cancel. So this fraction reduced all the way down to 6. You'll have one like that tomorrow, okay? Make sure you factor it and reduce it, okay? You will have one like that tomorrow, okay? That's not so bad. Okay, 14. Here comes the big ugly one. There's going to be at least one big ugly problem, and this is it, okay? You ready for the big ugly problem? Let's do the big ugly problem. Let's do 14 together, okay? 14 is the bad one, but I know we can do it if we are just patient, okay? I have an x squared plus 2x over an x squared plus 5x plus 6 minus a 1 over an x plus 3. Okay. When you add or subtract, you've got to have a common denominator. Okay, well, so the first thing I'm doing is like, what the heck? If I look at these two things, they're not the same. But I'm going to factor this one. So let me rewrite this. I'm going to factor. So I'm going to go x plus 2, x plus 3. When I factor my x squared plus 5x plus 6, factors into x plus 2, x plus 3. Now that's minus 1 over x plus 3. So here's the deal. If you need a common denominator, then they already both have a common x plus 3. Common denominator. They already have a common x plus 3, right? They need an x plus 2. So I need to give this fraction an x plus 2. So I'm going to give this fraction x plus 2 over an x plus 2. And then I'll have my common denominator. So what is my common denominator? It is a x plus 2 over an x plus 3. That's my common denominator, okay? What goes on the top, the numerator? Well, the numerator is going to have this x squared plus 2x, let's see, minus 1x minus 2 because I distributed the negative 1 in, okay? Well, I might be able to do something with that. So let's see, x squared plus 1x minus 2 over x plus 2 times x plus 3. Okay, will it factor? Because if it factors and cancels, then it reduces. So let's see, does it factor? I don't know. Let's check it out. I think this will factor. 2 and 1, right? X plus 2, x minus 1. Hey, I like this because then it will reduce. I like reduced fractions because they're smaller, right? If you can reduce it, you make it smaller. So I factor the numerator into x plus 2, x minus 1, cancel, right? And I finally get a nice answer of x minus 1 over x plus 3. Okay, that's the big one, okay? That's the big ugly one. Hopefully we can do that tomorrow, okay? All right, let's look at 15. It's going to get easier now for a little bit. Yes, I will wait for you, okay? 15 is going to get easier. Okay, get rid of it. Okay, whisk this away. All right, let's look at 15. Okay, 15 is going to be easy. 15, I've got negative 1 over x equals x plus 2 over 1. Okay, now, fraction equal to fraction, we're going to cross multiply, right? We're going to cross multiply. So I'm going to take this up here and this up here. So you get a fraction equal to a fraction, we cross multiply. Okay, I'll get negative 1 equals x times x plus 2. When you cross multiply, the fraction's gone. I was helping some kids yesterday. We were cross multiplying and they didn't get rid of the fraction. I'm like, come on, that's why we cross multiply, is get rid of the fraction, right? Okay, negative 1 equals, let's see, that's an x squared plus a 2x, right? Yeah, it looks like I'm going to need to factor. I will need to factor. But before I factor, let's bring the 1 over. Plus 1, right? Okay, I need to bring the 1 over so I can factor, right? Hopefully you guys see that. What times what makes 1? 1 and 1, right? X plus 1, x plus 1, okay? Many equations, I get x equals negative 1. Boom. Now, before I go any further, I know x cannot be 0. This answer is okay though, right? You guys agree x cannot be 0? X can't be 0? I like this answer. I'm going to keep it. Okay? All right. All right, number 16. The other hard problem, but we are going to be able to do it together, okay? There's two hard problems, 16 and 14. We can do this one. Negative 2x over an x plus 2 plus an x over 3 equals a 4 over an x plus 2. Now, what I want to do is make a common denominator. So before I go any further, what do you think? Common denominator. CD. What is the common denominator? Look at all three of these. What is my common denominator? X plus 2 and 3, right? It's both. So my common denominator really is going to be a 3 and an X plus 2. Good. I agree. So let's get a common denominator. Multiply this one by 3 over 3. Let's get a common denominator. Let's multiply this by an X plus 2, X plus 2, right? Let's get a common denominator. Let's multiply this by 3 over 3. Now,
Wait, could you not, like...
bring that over? Yes, you could. Totally. Yeah, I'm not going to teach that. Yes, totally correct. Yes, 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 yes. Shh. Yes. Okay. Okay. I don't want to confuse kids, okay? Now, we learned a couple of days ago, once you get that common denominator, I can just get rid of it. Do you remember how I did that? Yeah, so if I get rid of my denominators now, once you get that common denominator, you can get rid of it. And the reason why is if you multiply both sides by that denominator, it cancels out. So now I'm left with a negative 6x plus an x squared plus a 2x equals, so just crossed it out. Once you get that common denominator, just gone, bam. And now the fraction's gone, right? Now we're going to have to factor, but we can do that. So I get an x squared minus a 4x equals 12, just because I combined those two, right? I think I'm going to have to factor, so let's bring the 12 over. So to bring the 12 over, we'll subtract it, right? Probably going to need to factor, so let's go x squared minus 4x minus 12 equals 0, right? 6 and 2, x, let's see, minus 6, x plus 2, right, equals 0. Got our mini equations. So x is equal to 6, and x is equal to negative 2, but it can't equal negative 2. Why not? Why can x not? Well, I'm going to throw out the negative 2. If I put the negative 2 right here into the original problem, put negative 2 right here into the original problem, what happens? Equals 0. Can you divide by 0? Who's going to be sad? Cookie Monster. Don't divide by 0. So we throw away the negative 2. So make sure you check your answer. If you put a negative 2 right there, what happens? Negative 2 plus 2, divide by 0. Can't do that. Nope. Throw that out. Okay? All right, now, 17. All right, 17. So on 17, let's graph it. So before you do anything on 17, f of x equals x plus 5. And this will factor into an x plus 5, x minus 3. So, factor. First thing I would do is factor, okay? Now, tell me, before I go any further, what can x not equal? Okay, can't divide by 0. I agree. So what can x not equal? Negative 5, and x cannot equal 3, right? So one of these...
Negative 3 is supposed to be negative 2, not since...
Oh yeah, gosh darn it. Yeah, thanks, Caden. You know, I can factor, and I can multiply. Thank you. So, before we go any further, one of these two numbers is a whole, and one of these two numbers is an asymptote. One of these two numbers is a whole, and one of these two is an asymptote. Which one can we get rid of? Which one can we get rid of? Yeah, if I can get rid of this one, then it makes that the whole. So your whole is the removable one. Because if I can get rid of the problem, I got rid of the problem. So if you can remove it, if it's removable, then it's the whole. So my whole's at negative 5 something. And so if I get rid of the problem, I get this new equation. I get y equals 1 over x minus 2, right? And if I plug in negative 5 now, let's plug in negative 5. If I take my negative 5 and plug it in, I'm going to get, well, y equals 1 over negative 5 minus 2, because I can plug it in now. Once I get rid of the problem, I can plug it in, so I get negative 1/7. Okay, so there's my whole. That's not that bad, right? Factor, get rid of it. Once you get rid of it, you can plug it in. I'll say it again. Factor it, get rid of it. Once you get rid of it, you can plug it in, can't you? That's where the hole is. Now, where's my asymptote? Is it the other one? So my vertical asymptote is at x equals 2, because x can't be 2, okay? So my vertical asymptote is the other, right? My vertical asymptote came from that one. My vertical asymptote came from that one because couldn't cancel it out, right? I couldn't cancel out the problem. I'm stuck with the problem. Okay, so that's my vertical asymptote. Now, if I go to my graph, I know this much on my graph, okay? If I put down my graph, and I'm going to look at it on my calculator, of course. That seems like the easiest way to do it, right? Okay. I know this. Before I do anything, 1, 2, I know this. Okay. Vertical asymptote at 2. Okay, I know that. And my calculator is probably going to show me that, right? I might have a hole at negative 5 1/7. So I know for sure I'm going to have a hole right here. -1, -2, -3, -4, -5, and -1/7. So I'm going to have a hole right about there, okay? I know that. So then if I graph this on my calculator, because that makes it easier, and again, if you're going to graph it on your calculator, go back to the original. Don't forget when you graph it to use your parentheses, otherwise your calculator is going to give you a totally different graph, right? So go to my y equals, clear that. I'm going to go ahead and put it. Let's just check it out, but I got to go parentheses, x plus 5, parentheses divided by parentheses, x squared plus 3x subtract 10. I'm going to graph it. Okay, that kind of looks like what I thought it would look like. I got an asymptote at 2, right? And now my hole, I can't see it because it's like that big, right? But just going to draw it in. So here's what my graph looks like. And like this. All right? Everybody have that? So what about domain? Tell me what x cannot be. Domain. Okay, how about domain? So I know that domain of this, right? X can equal everything except x cannot equal what? 2, and x cannot equal -5. Okay. Last problem. How am I doing? And this problem is actually pretty easy. It's exactly what I showed you yesterday. Now, if you were absent yesterday, you got to listen, okay? If you were absent yesterday, you got to listen. This is not a hard problem, but you weren't here, okay? So, Beth and Tom are going to tile a floor, okay? Right? If Beth does a job all by herself, it's going to take 10 hours. But if Tom helps her, it's going to take 5.8 hours. So it's going to be faster because you got 2 people, right? But let's say Beth goes off and we fire Beth and Tom's on his own. How long would it take Tom? So the problem goes like this. We're going to take Beth plus Tom. We're going to add their work to get 1 job done. 1 job. Make it equal to 1. We're going to have them come on into my house and do the 1 job. And the 1 job is tiling my floor, okay? Best ratio of doing this, she can do it all by herself in 10 hours. If Tom does it by himself, we have no idea. X hours, right? Now, when we add them together, their total time is 5.8. Okay? So you put the total time, because we're going to add them. This time plus this time, their portion of it, their ratio of it, plus this ratio to get the 1 job done. Okay? Now, let's go ahead and solve. So first of all, how about a common denominator? Okay? What do you see for a common denominator? Well, 10x, right? You guys agree? 10x? 10x will be my common denominator. So let's multiply this one by x over x, 10 over 10. Let's see what we get. All right, so I'm going to get a 5.8x plus a 58 over my 10x equals 1. Okay? So I got my common denominator, 10x. So I multiplied 5.8x, multiply 5.58. Okay, now to solve, we're just going to cross multiply. Okay, so let's cross multiply. Bring that up there, multiply that. I'll have a 5.8x plus 58 equals 10x. Right, just cross multiply. So sorry, it's so sloppy. To solve, I'm going to go minus 5.8x minus 5.8x. So I have a 58 equals, what is that, a 4.2 probably? 4.2x, right? I'm going to divide, and I'm going to figure out what is 58 divided by 4.2, and I get an answer about 13.8 hours it'll take Tom by himself. Okay, how's that?
Awful.
That's what I got. So I always like to say this is probably the